This is Joe Mako, and I've got Matt Button with me, and today we're going to go through another question on the forums, but instead of just answering the question, we're going to dive really deep into what it means for data densification inside a Tableau. This is a really mysterious topic, one that admittedly even I don't fully understand, but I tried to have this working philosophy of it, and working with people like Jonathan and Richard and people like Matt here today, we're able to refine our awareness of it so that we can continue to work with Tableau instead of just being frustrated with it, that we can put some terminology to this so that we can talk about it and be aware with it and work with it. So how does that sound, Matt? Anything to start off with?
No, I think that sounds great. I'm just happy to watch and learn, and working on changing my mental model as well. So.
Okay, great. So here's the question that we have here today is they have a chart where the window average was apparently not working for them, or maybe there was another thread here too that was really similar. Let me see if I can find that thread as well here real quick. That there was a window average thread, and what was the other one? Can I add underlying rows to the data in Tableau? So let's pull this one out too. That both of these two threads are related to each other. Where they've got this underlying data, when he brings it into Tableau, it's not all marks are there, and he wants to get to something like this. But then when he changes the arrangement to pills, it disappears. That what's going on here is sometimes data densification is on, and sometimes it is off. And what I've created here with the work of Jonathan and other people and Matt's help is a document to cover all these different terminologies that we're going to talk about today. Because this is such a hard concept, it's not just going to be in a video. We'll also have this document available in the description below, along with links to these two threads where Jonathan, Matt, and I talk back and forth about different things, along with Jim Wall is in there too, offering his solutions to the same problem. And so what we have here is some fundamental terminology that if you've heard me talk about Tableau before, you've heard me talk about this idea of the 4 pill types, that there is 2 binary options together that give us these 4 different pill types. Now let me open up a visual of this as well, if I can. Let's see here. Open up this. This was the presentation I gave at Tableau. This 4 pill types of 2 binary options gives us 4 kinds of pills, where we've got dimensions and measure, and then continuous or discrete. And so my definitions for these is that a dimension is a pill that is in the group by clause. It's setting the level of detail, it's setting the granularity, whereas a measure is simply an aggregate, or it is happening after aggregation. And then a blue versus green, that's going to be your pill color of discrete versus continuous. And a blue simply means each value individually, either each dimension value or each result of that aggregation. And then a continuous is that green pill where those values are plotted on a continuous scale. So continuous can really only be applied to results of measures of dimensions that are either numeric or dates. And that gives us the 4 pill types, the combination of those terms, those 2 binary options. The next thing I want to talk about is this general concepts or some other terms that we may use here today. This idea of compute using. That what compute using refers to is the addressing. That when we're creating a table calculation, we specify what do we want to use for compute using, and that's also going to be the addressing. That whatever we specify for our compute using, all other dimensions will be used for partitioning. So in other languages like Oracle or whatnot, we specify what we want to use for partitioning, and everything else is used for addressing. Whereas inside a Tableau, we specify what we want to use for addressing, and everything else will be partitioning. And this idea of relative compute using versus an absolute compute using, that when we're inside a Tableau and we have some type of table calculation. Let's say I have region out here, and let's make an index table calculation. That this index is using table down right now, or I could separate this out into customer segments like this, and it's still defaulting to table down. That things table down, table across, cell. If we had a pane inside here, let's see if I can bring out something else like this, that now we have this pane across, pane down. All of these different options here, these are all relative compute usings because they are dependent on your arrangement of discrete dimension pills on the columns and rows shelf, versus if I were to specify an absolute, meaning I point to something specific here, then we're going to get that same computation irregardless of the arrangement. So for example, if I said pane down, what I'm saying here is the effective compute using is order priority, and therefore we are partitioning on both customer segment and region. So I could say compute using, order priority, and nothing would change. Now because I've changed this to be a absolute, meaning I've referenced the dimension exactly, or I'm using an advanced compute using, I can move these pills around and the value will continue to stay the same. All the criticals are 1, all the highs are 2, all the lows are 3. And so the computation that comes to that mark stays the same irregardless of the arrangement of the pills on the columns and rows shelf. Versus if I have pane down, right now critical is 1, high is 2. When I move these pills around, now it changes. Now critical central is 1, high central is 1. So now all the centrals are going to be 1. If I wanted this as my compute using, I could say compute using region. And now that sets it as an absolute. Now when I move region over to here, all the centrals are 1, all of the easts are 2. And so that's that difference between relative and absolute, that a relative compute using will be based on your arrangement of pills on your columns and rows shelf and marks card, and also your table calculation of choice, that can impact it as well. And then absolute is when we reference it directly. And so right now, if I say pane down, the effective compute using of this matches the absolute compute using of selecting the region, that we can see it does not change. And so that's that concept of compute using, relative compute using, and our effective compute using. To show you the example of where does it depend on the type of calculation you use, that the total will behave differently versus a window sum. So for example, if I have order date with a month out here, and let's put some sales out here, and we have different regions per se. If I created a calculated field that says a window sum of the sum of sales, okay, that when I drop that out, there's another axis, we can see that we get a separate line for each one of these individual regions. Let me put region on color so we can see it more clearly. So this is giving me the total sum of this entire green line across the entire time, right?
Yep.
And that gives me this value of 21 million. And if I look at this plot here, that's plotting it at 21 million because it is set to be compute using table across. And what's on our column shelf is the month, so that's being used for addressing. And because we're using window sum, what we have on the marks card and on the row shelf will be partitioning. So we're partitioning by region to get that window sum of the sum of sales across all the months for each individual region. Versus if I were to make another calculated field and call it total sum of sales, that generally these two would be about the same. The window calculation is an aggregation of an aggregation, whereas total is going to be an aggregation at a different level of granularity. But because we're using sum, they should generally be the same. And when I pull this out, I get a single line at this total sum of 30 million, which is all of these all together. So even though they both have the same compute using of table across, window sum table across, total sum table across, they have different effective compute usings. That the effective compute using for this one is not simply just order, date, or region. It is the combination of them. That for a total table across, it's going to use both what's on the column shelf and what's on the marks card for addressing. Okay, so that's that.
Yep.
Effective compute using is not always the same, and it depends on your calculation as well. Okay. Next term that we have inside of here is the idea of a range-aware pill. That a range-aware pill is based on your data type, either a date or a date time or a bin. And that what range-aware means is that it has a min, a max, and an increment. So when I look at something like a date out here, that this pulled out to be at the month, that this is a range-aware pill. We have a max month, we have a minimum month, and we have an interval built into it, in that we said at each month. So whether it be a date trunk like these down here, or a date part, that these are going to all be range-aware. One of the exceptions is when we have a date time. For example, if I created a now calculation, this one would not be a range-aware as an exact date. And the reason why is because it is a date-time data type. And so it is not a range-aware pill, because if we did make it a range-aware pill, it would be every individual second. And so Tableau smartly does not enable it to be a range-aware pill for us, which is good. The other type is a bin data type, that if I create bins from here, and say, let's put it at 1,000, that we now have a bin, or even this profit bin here, which was already here, that we could specify with a parameter even, that the interval is what we have inside of this edit here, of the size of the bins, and then the min and the max is going to be those individual values. Okay? And we'll get into that again in a little bit later. And then opposing shelves. This is a shortcut to say the columns and rows are going to be opposing shelves. And it's an interesting way to think about Tableau, that what we have on the columns and rows are opposing, where we're telling Tableau that this is something interesting, that we want to look at this idea of category versus container, or department versus container, and that this is meaningful for us, this cross-tab arrangement of dimension versus dimension, and specifically discrete dimension versus discrete dimension, that this is creating a grid for Tableau to look at, that these are opposing shelves, versus having it on the marks card is not necessarily an opposing shelf, but it can be used that way as well. All right. So that covers our initial general concepts. And then we've got this idea of terms directly related to our discussion. This idea of sparse data is where all the potential combinations do not exist in the underlying data, or they're simply not returned by that query to the underlying data. So if we look back at this combination of department and container, that we've got 7 possible containers and 3 possible departments. So overall, we could have 21, 3 times 7, but we only have 20 marks because that is what we have in the underlying data. Or I could also come into here and filter one of these out to exclude it. And now we only have 19 marks where we could have 21. And so again, that's another potential place where data densification could happen because the data is sparse. And then the next concepts are this overall idea of data densification. That's an umbrella term to describe that Tableau is adding marks where there is no data returned from the underlying query to the data source. And the 2 types of data densification are either domain completion or domain padding. That domain completion is adding marks for the combination of dimension values that we have returned, whereas domain padding is adding in potential values for the range aware pills. Okay? It's slightly different. They're both data densification. They're both adding marks. One is based on dimension value combinations, and the other one is based on the range aware pills. Okay?
Yep.
And it is possible to have both domain completion and domain padding happen at the same time. So that's something good to be aware of, that it's not either or, you can have both as well.
Right.
The basic requirement to turn either one of these on, for domain completion, you have to have at least 2 dimension pills, and then for domain padding, you need to have a range aware pill. Now understand these are necessary, it's not always sufficient, and there are numerous exceptions. And so let's get into some ways to turn on domain completion. We're going to cover ways to turn on domain completion. We're going to cover ways to turn on domain padding. Let me just put that in there as well into this document. Ways to turn on both and ways to turn on both. Okay, so bold that and bold this. So we're going to cover individual ways to turn them on, and then we're going to cover a way to turn them off, both for domain completion and domain padding. And we're going to cover some exceptions to turning them off. And we may cover each one of these as we go through each one of these types. So the video may not match the document exactly, but this document has a good completion of complete document of what we're going to talk about here today.
Absolutely. Thank you for putting this out there and putting it together. You and all the other people that have helped along the way.
Yeah, my pleasure. And just to be aware, another word of warning, that this is not completely accurate, that the way that Tableau works in the code underlying does not match this documentation or doesn't match this video. It's just this is currently the way that I like to think about data densification, to break it down to these 2 categories, and then the multiple ways to turn each one of them on just makes sense to me currently. If there's another way that makes sense to you better, that's great, because it's what's really neat about Tableau is that there's multiple ways to approach the same thing, and it's just trying to be consistent and aware. And even with this document, it's not a complete document, because there's going to be exceptions or other edge cases, and as Tableau goes between different versions, these things will disappear or other ways will be added, because it's a very complex piece of software. But Tableau is aware of the complexity of this, and hopefully in future versions this video will again become obsolete and it'll become easier to work with these things. Okay?
Yep.
Excuse me. So let's talk about the first one, which is crosstab. That this occurs when there are discrete dimensions on opposing shelves and a table calculation configured to use one or more, but all of those dimensions as addressing as the compute using. So let's take this simple example here, where we have a sparse data set. We've got department and container, and the domain is not complete. So we can complete the domain with a table calculation. And when I drop this out here, we see we got an additional mark. We now have 21 marks. If I put it onto the text shelf, we can see it's going table across 1, 2, 3 for us. That it added that mark. That Tableau densified this after the data was returned from the query. And then it did the table calculation after the data was densified. And that's why this table calculation is able to give us a 2 there. Versus if I drop out sales onto the text shelf here, we can see that it's giving us a blank, or it's giving us a null value there, that there is no sales, so there's nothing returned from the underlying data, that it's just a empty mark. Excuse me, gotta take a drink of water here. Okay, that's better. So this is a mark that's available to Tableau and the table calculations. And it has been densified because we have these 2 dimension pills, and they're on opposing shelves, and we are using one of them effectively. Table across is saying use department as compute using, and it's giving us that extra mark there. So if I put it out like this, we can see as I change the compute using to table down, we still get the densification. It's just addressing differently. Now it's addressing on container and partitioning on department. And if I change it to something like across and then down, the densification turns off, because now I'm using all of these dimension pills as addressing. And so we go back down to 20 marks. That's one of the ways to turn it off. And so what we could effectively do here is we could say, I want to bring over both of these as addressing, and then I want to restart every container. And so this still is going to keep it on, because it's effectively, we are addressing on just department and partitioning on container. So it's still turning it on because we've got it on these opposing shelves. So there's all these different ways of turning it on and off. And so it does require a little bit of experimentation to get it exactly what's going on. And using this index is a nice table calculation to see when is it going on or going off, so that we can have a little bit of better control over it. And so that's the first one. Another way to turn it off is if I had compute using, let's go table down, and if I pull it down to here with both of the pills on the same shelf, now we're back down to 20 marks. So it's back off again. Or if I took department and moved it down to the marks card, it is still off with 20 marks. We're not getting all of those different values in there. And we can see for this one, we're counting up to 1 through 6 there. This idea of it being on or off is really frustrating, because sometimes it would be really great if we could have it be on. An example of this would be if I wanted to put an index out here with a discrete, and I get this nice rank 1 through 7, densification is on. And if I wanted to make some type of chart here with the bars, it still looks great, but now when I want to turn this into a stacked bar with department on the color shelf, now it goes all crazy like, because densification turned off. We're back down to 20 marks. And so to work around this, because there's really not a good way to directly turn this on, or maybe if we tried that way that we did there, but sometimes it doesn't always work. So we can edit this table calculation and say, I want to address on both container and department, and then I want to do at the level of container, meaning I want to increment each time the container changes and basically ignore department. This gives awareness of all these different values here, so that the index incrementing can see that there are 7 potential containers, and it will only change or only increment when container changes, and then we get that display that we're looking for. And of course we could sort this descending on sum of sales, and we get a nice stacked bar chart with index incrementing the way that we expect it, and data densification is off. So even if it's off, there's ways that we can modify our compute using to take that into account and get us the computation that we're looking for. Okay. Any questions about this, Matt?
No, I don't have any questions, but I might mention that Jonathan has written a nice blog post that talks about ordinal calcs and at the level on his blog. So there's a lot of information there as well to go through.
Yeah, go ahead and send me that link, and we'll add it to the description below.
Okay.
Okay. So that basically covers the first idea of this crosstab completion and when does it turn on and off and the exceptions to it in relation to table calculations. Next one is dates. So Tableau will automatically complete the domain for date type or date data type discrete dimensions when the table calculation is configured to use that date data type dimension as the addressing or the compute using. So let's say we have something like this where we've got, and I think we showed this in our last video, but we'll just cover it again briefly here, that if we have a customer and we have, let's say, some months, let's pull out these months here, and cancel that, turn this into a discrete, and we'll keep just a couple of these customers, keep only. So we've got these customers with some different months available to them. If I wanted to get just the first month for each individual customer, we would generally expect to say compute using on order date. But what happens here is domain completion has turned on. That this is not necessarily domain padding, this is just domain completion, being that the combination of all these months for each of these customers has been completed. That we have a 12 different potential months, and you can see it's not padding because we're going from November 2010 to October 2013. That's more than 12 months over that time. So it's just doing the completion and not the padding. And that this is that classical crosstab arrangement here, but even with them on the same shelf, if this was a string or a number, that this would not be domain completion right here. You know, as we saw back here at one of these examples, if I could show it again, that if I have the category or even department and container, that if I have this index out here using just one of those, oops, compute using container, that it does not complete the domain up to 21, versus this one is completing the domain up to those 3 by 12, so we get 36. And that's because what we're using as our compute using is the date data type. And if I had this at, let's say, multiple levels here, both week and, let's say, year and quarter, that it is completing it across both of these. If I were to say compute using order date, that we're pulling over both of these and we're doing that full domain completion. Every possible year and quarter combination is densified to each of these customers. But a way to turn this off, if I go back here a little bit, go back to where we have month here, is a way to turn this off is to bring over both of these onto the addressing and say restarting every customer name, and now the domain completion turns off.
Right.
So that's a way to turn that off. Going back to this example over here where we have the container and department in a crosstab, one that I forgot to mention as a way to turn this off is we can pull department down onto the marks card and turn department into a measure pill, and now the domain completion is off, that this jumbo box office supplies combination is not densified. We're at 20 marks. So it's this combination of discrete dimension, that I can have a discrete measure out here and then the discrete dimension down here, and it will give us that same granularity of the view, but without the domain completion, versus having this date over here. If I say compute using order date and I move it down to here, it turns it off as well. So it's one of those things of that if I have this month out here as well, we get the completion. If I turn this into a measure, let's say minimum, and the completion is still not there. So this is one of those cases where it's kind of, it's still staying off. It's another way to turn it off, and both of these are the same ways of turning it off. So that I've got my compute using on just a date, but because the date is down here on the marks card and we only have a measure up here on the columns, it does not turn on. And it's the same case as this. Measure up here, dimension down here, it turns off. Okay?
Yep.
So the next case of turning it on is a mark type. And this one is more of an edge case. You generally may not run into it, but when you do, it can be kind of surprising and unexpected and inconsistent. Because one of the things that's really nice about Tableau is that we can switch between different views, and our data we would expect would not change. But this is a case where the data does change based on your mark type. So an example of that, which is directly related to the question that we had out here on the forums, if I could find that one real quick, that where the solution that Jim came up with here was to turn on stacked marks with a line mark type. And what's happening here is domain completion because of the mark type, and the pill here is a continuous, and he has stacked marks on. That when I have this incomplete domain, again, let's take this department and category, or department and container rather. So this department and container, we are with 20 marks. I've got the automatic as a text type, but when I change it to a line mark type, now I get 21 marks. And this is because the domain was not complete. We have these two dimension pills, so the domain becomes completed. And this happens with other things as well. Let's see if I move container down to here, and it goes off because it doesn't have that right combination. But if I leave container up here, where we have the 7 individual cells, the 7 panes up here, the 7 individual spaces, we get 21 marks because department is down here. And so this is because of the mark type. If I change it to be a circle, we go back down to 20 marks. We change it to be a polygon, we get 21 marks. We change it to be an area, we get 21 marks. That this is because of the mark type. Now, if I had this as a line type, but then a continuous up there, let's see if we can find a good example of that. Let's take us to a couple of customers. Let's select just a few of these. Okay. And so with these customers, and we'll put this back to automatic, we have ourselves a date. Let's put it at the month value here. That this is not a complete domain. This is sparse data. And if I change it to be a line type right now, it still stays 13 marks. And that's because we have a continuous out here. But if we were to turn on stacked marks, and with customer down here, and let's put some type of axis over here, that we go up to 66 marks. That it turns on when we have these continuouses out here. versus if I had this as a discrete, that we get the 66 marks, and I can turn this back to automatic, and we still get the 66 marks. So it's this combination of, do I have a discrete or a continuous, and my mark type, and this combination of stacked marks. So it's a really tough combination of all these different things working together, but it's all domain completion, completing the domain of this sparse data of a combination of dimension pills, that this is not doing domain padding, that this is domain completion, this combination of dimension pills, and whether it's a continuous axis or a discrete axis will either enable the stacked marks on or off to turn on or turn off the domain completion. Because if I turn this to be continuous right now, domain completion goes off, and if I come into here and say analysis stacked marks on, and now it goes on. I now have 66 marks. Okay?
Yep.
And so what does this really impact? This impacts our table calculations, that if we've got something like a size out here, create something else. I want to create a new one. So create a calculated field, size, E, and okay, just a little bit smaller so I can click my button. And when I pull out size onto the label shelf, it says 11 because it's defaulted the table across. But if I modify this to include all the dimensions in the addressing, now we get 66. And you also saw that how it connected the lines changed based on whether densification is on or off. That now we get 13. So this impacts our computations, even though it may not have a visual impact sometimes, or the type of visual impact it has. It's just important to be aware of when is this densification turning on or off, and watching this marks card is really important.
And Joe, with that, when you were doing mark stacking on and off there, it did not matter if it was a discrete or continuous month of order date on columns. It just, the default for those was changing. Is that what was happening?
So it does matter about this combination of discrete and continuous and stacked marks on or off and your mark type.
Right.
So if I were to have a circle mark type, that changing between stacked marks on and off does not densify the data. So the first requirement is that you have this mark type of line or area or polygon.
Right.
And then if it is continuous and you want densification, then you can turn mark types on and you will get data densification. If you have a continuous and that particular mark type and you want densification off, then you turn stacked marks off. If you want densification on, then you turn stacked marks on with the continuous. Then when we have a discrete, then it doesn't matter whether the stacked marks is on or off. You're still going to get 66 marks. So the on or off will impact line type and continuous up here versus mark type and a discrete. You will get the densification.
Right, and we're seeing domain completion there. Okay.
Yep, this is domain completion because of your mark type. And when you change the mark type, the densification goes off. And that's irregardless of your stacked marks. So it's this stacked marks and mark type and continuous versus discrete, which is really complex, which I hope Tableau corrects sometime. And then let's go back into our document. See, our next one is at the level. This is another kind of edge case situation, but good to be aware of that it can happen. Is we've got discrete dimension on the rows or columns and another discrete dimension on the marks card, and a table calculation with an advanced compute using that's using the dimension that is on the marks card at the top and then setting at the level to use that dimension on the marks card.
Right.
So to show you...
Did we already see that, Joe, with the stacked bar chart that we did?
Not quite. Not quite.
Okay.
But we may have showed it briefly, but it's similar because these are all domain completions. That
Right.
This stacked bar chart over here, I used at the level, but what did I use at the level? I used at the level of container.
On container. It wasn't on
If
the marks
I
card.
changed this compute using here and put department at the top and then said at the level of department, and notice department at the top, department on the marks card, container lower, container on the rows or columns, and then department at the level, department on the marks card. Now we get our 21 marks. But our index isn't doing the counting that we wanted. It's doing a different counting, but it is turning on that densification.
Right.
So, yes, that is an example of turning on densification via the compute using. And we only have a single dimension pill, discrete dimension on the columns or rows, and the other one is on the marks card. The one that's on the marks card is at the top of the advanced, and it's being used at the level.
Right.
Okay.
Now, and if we added another dimension to rows, we would still want to use that same concept of having the top level addressing dimension.
Yeah, once you start bringing out 3 dimension pills, now it starts getting a little bit more complex, and you have to really watch what's going on. So if I'm dealing with 3 dimension pills and I want some type of densification, I'm going to pull them out here to the rows and column shelf to see what's going on, because it can be quite confusing. So if I pull out order priority, let's do department and category out here. So this is not going to be complete. If I put this up here, we see we got some sparse data. I put this up here, we still got some sparse kind of data in here. Not quite as sparse. Let's see if I can get another thing in here. How about customer segment instead of that? Does that give me something here that's a little bit more sparse? Or how about ship mode instead of customer segment? There we go. So this is sparse in multiple ways. That if we tried to look at this pane, that this pane over here is not complete. If we wanted to look at this individual row segment here, this row segment's not complete. All sorts of stuff. This is very sparse data. And when I'm using a table calculation, we can get all different types of densifications. This first one is using table across, so we basically fill out the complete thing.
Right.
If I change this to just be ship mode, now I'm just completing this individual cell here.
Right.
Versus if I were to say compute using department, now it's a very different looking thing, and it's kind of harder to figure out how exactly is this densifying. So my general practice is I put what's used for partitioning on the left, and I put what I'm using for addressing on the right. As we look at this, I've got compute using of department. So department's on the left right now, and it's kind of confusing to look at this. If I move department over to this side, now it's a lot easier to see that, okay, I'm taking if anything inside of this cell exists, and I'm densifying it. Because if I were to turn this off real quick, we could see that there is an office supplies and appliance, but there's no furniture or technology. So when I pull that out there, it's densifying furniture and technology. That a way to think about it is that whatever you're using for addressing, that's what's being densified with inside of that partition, that combination of ship mode and category right now.
Right.
So it is quite difficult the more dimensions you bring out there. That's why it's advisable to have the least amount of dimensions that you can. That if it's just going to be additional detail, something like, if I had category out here as well, because category is hierarchical with inside a department, I would remove department or turn department into a measure, and that way it wouldn't impact our table calculation, computation, partitioning, or addressing. So it's just some techniques of put your partitioning discrete dimensions to the left and put your addressings to the right, and it's easier to figure out what's going on here.
Right.
Okay. And we've got just a few more minutes here. Let's see if we can go through these last two here. Let's cover this edge case, or no, let's cover domain padding first. Yeah. So domain padding is synonymous with show missing values. That when we have a range-aware pill on the column shelf, we can turn it on from its right-click menu. So I think we may have shown this briefly. If I bring out order date as a month here, and let's filter to just a couple of customers, none, and there we go, we get some customers, and we'll put this to this kind of month. That this is, again, not domain padding complete, that we don't have all potential months. So we can turn on by saying show missing values. And this turns on domain padding. That this is not domain completion, this is padding, because it's coming up with values that do not exist inside the data source, but it's coming up with values based on the min and max and the incrementation that we specify here. So if I change this to quarter, we get all those potential quarters padded in. And this turns off sometimes. If I were to pull out sales here, we went back down to 7 marks, or if I make this to month, we go back down to 9 marks, where we have 37. This is domain padding on. We pull out a continuous out here, and it turns it off. That can be quite frustrating. So how do we turn it back on? We pull out a table calculation, and now we have it on, and we can impact this via the format, whichever way we want to deal with it here. We can say show at default value, and now we have something that plots it down there. We get our 37 marks. This is domain padding on, because this table calculation is effectively using this date pill, this pill that has the show missing values, the range aware pill configured with show missing values, as the compute using, as the addressing, or as the effective compute using. Okay?
Yep.
And so if I were to take this pill and move it down to the rows shelf, or even let me go back to this a little bit. So we've got domain padding on right now at the simplest way. We've got an incrementation, we've got show missing values on, but if I move it down to the marks card, it turns it off. And so also, if I had this off to start with and put it down here, there's no way to configure it from the marks card. That option disappears.
Right.
But again, if I have it out here and I turn it on, and then I have a table calculation that uses it as an absolute reference, that domain completion, or that domain padding rather, that pill, and pull it down here, and it stays on now. Even though it doesn't give me the option in the menu, it's staying on because we configured it while it was on the columns or rows shelf. And so these are all just little exceptions and ways to turn it on and off, and what keeps it on as we move it to different shelves and whatnot. And so that is domain padding, which is this show missing values option. And then we can also have them both at the same time. So in this case, I've got the domain padding on. If I pull out something like region out here, that this is now both domain completion and domain padding happening at the same time. And it doesn't have the two discrete dimensions on opposing shelves, but we do have the dimension here. And so if I wanted just to complete it for some of them, say I turn this to a, turn this off, that I just want to fill in between here and there, that what I can do is go back here just a little bit, have my index, pull this down to here, and then turn this into a measure, something like minimum, and it looks kind of crazy up there, but we do get the densification. It's just not filled in. So I turn this to a continuous. We get our 97 marks, and they're there, but they're just not filled in because this is a measure pill, and so this measure is evaluated before densification. We need to fill it in with a table calculation. So we can create a calculated field for our date field. And the way that we can create this is with a date add, and we want to add a month, and we want it based on our index -1, because index starts counting at 1, and I take a total min of our date. Let's do a date trunc on this. Date TRUNC to the month level of our order date, and close that all off. And so this will fill our date to the month level, and so I use this out here instead. Let's turn it into a continuous, convert to continuous, and pull that out in place of it, and set the compute using to be order date, and there we go. We now have the padding without the Completion. Okay?
Yeah.
So that's kind of complex, but I'll put this calculation in the description because I think it's a really useful one when dealing with this. And notice that what I have here for the date add and the date trunc date part matches what I have for my incrementation on the pill that has the show missing values turned on. Okay? So I would match that if I want to do quarter or week or whatever. And then the last one is another edge case situation here of turns on both of them. And this is with the show empty rows and columns, which is from the menu option analysis table layout, which I don't think a lot of people use inside of Tableau. So it really is an edge case. Now, for some reason, my Window's yelling at me because I've got another appointment coming up here soon. But okay, so we've got a few more minutes to cover this. A way to see this is if I pull out year of order date, and you can see that I do not have show missing values turned on. If I remove these here and exclude, show missing values is not on, but if I did turn it on, it would come back in and fill those values. So I do not have that turned on, but when I come up here to Analysis, Table Layout, Show Empty Rows, it does turn it back on, even though it's not configured at the pill. So Show Missing Values is not turned on, but because I have Show Missing Rows, it is turned on, which is kind of strange, but useful at times. And it also is turning on densification, domain completion at the same time, so it's filling it out all the ways. So if I were to say analysis, table layout, don't show that, and let's find something that is not going to be complete across all the ways. Let's say some customer names, that not all these customers happened in both these years, but when I do analysis, table layout, show empty rows, now it fills out both ways. It does both domain completion and domain padding. It's just something to watch out for as well.
Be aware of it. Yep.
And with that, I believe we covered everything in the documentation here. I didn't do it in the exact order that we have it documented here, but I think all of this content is inside the documentation as well. If there's any exceptions or anybody watching this finds something else, please let us know, send us an email, and we can add it to the document. Any other final comments here?
Nope, I sent you the blog post of Jonathan's to add to the document as well on At the Level. I think it's helpful to have all this information. Hopefully people can watch and study and make connections in their understanding.
Awesome. All right. Take care. See you next week.
All right. Thank you. Thank you, Joe.